Good evening, wherever you are around the world. My name is Michael Ortega. I'm here with the Predibase team. We're super excited to have you with us for our virtual hands-on workshop. We're going to show you how to efficiently fine-tune and serve your own open source LLMs for a number of pretty cool use cases, and specifically make those LLMs rival GPT-4. So show you how you can take an open source LLM and get GPT-4 quality through the act of fine-tuning. Excited to have a crowd here. I see people are chiming in on the chat. We have folks from all over the world. We have a couple polling questions that we'll share about your experience with fine-tuning and your motivation. You can take those. But let's jump into the next slide here. So a couple quick webinar logistics I'll cover. The lines are muted, but we do have a very active chat, and we also have some of our solution experts and engineers and technical folks in the chat who can help with questions. We know it's going to be a technical session, so if you have questions, please put them in chat. We will also do a live Q&A at the end. So we're going to try and get through the content and the workshop portion, and then hold the questions for the end, but you please put them in the side panel, and our teams will answer them throughout. But we'll also do live Q&A when we wrap up. And next slide. Oh, and I'll mention as well, because this comes up a lot, the session is recorded, and the replay will be automatically sent to everybody after. So if you have colleagues or friends who want to partake in it, but weren't able to, you can share it. So a couple of things today. So in today's workshop, we are really truly doing an end-to-end fine-tuning and serving use case. So we'll show you how you can get your data, your open source model, fine-tune it on a set of data, and then actually prompt it and see the results, which is super cool. So it'll be a full end-to-end use case. Now, a couple of things. This requires obviously some comfort level with Python, as we'll be working in a notebook environment. But you have two options here. If you just want to watch and follow along that way and not actually write code or get the notebooks, that's totally fine. You can do that. We have a great host here, Alex, who's going to train you. You can just watch. But if you would like to actually participate in the session, I'm going to push a button to you now. We offer $25 in free credits for this session. There's a very short form you need to fill out. If you fill out that form, you get $25 in free compute, which will allow you to fine-tune a number of models, serve them, prompt them, and play around Predibase. But will allow you to then also use today's notebooks. So I'll share those. And if you missed the link, I'll put it in chat. It's also up here on this slide. Let me just copy it over in chat right now. But if you plan to actually, want to dig into the notebook and make it work, these are two links that you'll want. Here you go. There's $25 in free credits, so you can train your models and today's notebooks. All right, let's keep moving. All right, so I'll do a brief introduction today. We have two great speakers. Can't think of any better to talk about both fine-tuning and LLMs and how to work with them. We have Abe over here at Predibase, who's on our product management team, who leads a lot of the direction for sort of the new innovations we're building, whether it's fine-tuning or serving capabilities, and has been with the company for a couple of years now and has incredible experience and depth of knowledge on LLMs. Joined by him is Alex Sherstinsky, who's our head of DevRel here, works very closely with our open source community, as well builds hands-on tutorials and helps folks learn the ins and outs of how to use the platforms, the open source tools, and deliver on cool use cases like the ones that we'll be covering today. So with that, I'm going to pass it over to our speakers. And again, please put your questions in chat, and we will be there to help you.
Awesome. Thanks, Michael. So I wanted to begin today's workshop by just setting the stage and the context for what we're going to cover. So in the first 30 minutes or so, I'll cover an introduction of our recent launch with LoRaland, and then I'll cover an overview of adapters and why we believe they're the future of fine-tuning. That will then set the context for Alex, who will introduce you all to Predibase and lead everyone through a live deep dive workshop of how you can fine-tune and serve your own models on Predibase. Cool. So let's talk about LoRaland and some of the underlying motivations of our recent launch. And so for those who are unfamiliar, LoRaland was essentially our playground that shows how we fine-tuned 25 different models that rival GPT-4. And by rival, we mean that are at equal or better performance. And so today we couldn't be more excited to show you how you can build your own version of LoRaland, specifically in the customer support domain. And so before we dive into a demo of LoRaland and why we built it, I think it is helpful to take a step back and see how most teams are experimenting with AI today. We see that most teams start with a commercial LLM like OpenAI or Anthropic, and the appeal is pretty clear. Users now have access to a large language model with trillions of parameters that are essentially complex reasoning engines, just at their fingertips. I think very quickly, however, we start to see a lot of these teams run into hurdles with these commercial LLMs. The first is cost. So we've seen some companies spend upwards of millions of dollars a year once they have OpenAI running in production. Second is latency. Because these models are so large, you're really stuck with whatever speeds these vendors choose to give you. And for latency sensitive use cases, getting a response from GPT-4 in 5 to 10 seconds just isn't going to cut it. And then lastly is the idea of ownership. And so if you subscribe to the theory that your data and your models and your weights are your intellectual property, then it's clear that having ownership over your model is going to be the key to building a long-term defensible generative AI strategy. And so if OpenAI isn't the future, then what is? We believe that while it's common to start with OpenAI, using smaller, fine-tuned open source models when you're ready to move to production often provide a better set of trade-offs. And specifically, when we talk to organizations today, we find that while using a large language model like GPT-4 is fine, what organizations are really trying to do is solve specific tasks, such as building a question and answer type chatbot, or building a text classifier or summarizer, or even generating structured output like JSON. And so in addition, by using these open source models, you can immediately see a few different benefits, such as the ability to own your model, to no longer send your private data to OpenAI, and to make use of smaller and faster LLMs that you can ultimately control. And so now let's look at a real example here. And so here we have this use case of JSON generation. And so what we did is we ran benchmarks comparing fine-tuned LLMs versus their commercial zero-shot counterparts. And not only was fine-tuning actually more accurate, in this case around 40% for this task, it was also a 250 times smaller model. And so why does a smaller model matter? Well, if you look at the cost of Predibase serverless endpoints versus OpenAI, there's about 100 times price difference between these two models. And so with open source fine-tuned LLMs, you're truly getting the best of both worlds. You're getting a more accurate model at a fraction of the cost. Cool. And so let's dive into LoRA land, our playground for fine-tuned Mistral 7B adapters. I think the easiest way to show this is actually to look on the left here. We can see a GIF of what this is, and this is actually live today. So if you were to go to predibase.com /LoRA-land, you'll see our adapters that are live and ready to run. And so what you can see here is that we've actually fine-tuned Mistral 7B on a variety of different tasks, including things like mathematics, summarization, text generation, and many others. And so what we saw was that the fine-tuned Mistral 7B was actually able to outperform GPT-4 in almost all of these cases, right? And so I'd very encourage you, especially after the workshop, to go take a look at our demo and kind of play around and try typing in your own queries and just get a sense for how these fine-tuned models perform out in the wild. We actually saw that Jan LeCun, chief scientist at Meta, quote tweeted our launch and agrees and has conviction that the future will indeed be a series of small, fine-tuned, specialized models. And so there are many more examples, but would definitely recommend you checking it out after the workshop. Cool. And so just to kind of emphasize some of the benefits that we wanted to kind of showcase through LoRA land, I think the first was just the idea that smaller, fine-tuned open source LLMs can actually outperform GPT-4. And so we saw this across all 25 of our fine-tuned models. The second is the breadth and flexibility. So we saw that even though these were very different tasks that were kind of across the board, we saw that fine-tuning one specific Mistral 7B was able to kind of outperform GPT-4 on each of those specific tasks, right? And so there's this really broad flexibility of fine-tuning that is really dependent on the data set that you have and the tasks that you're trying to achieve. And then lastly, this is the production application that's available now. So we definitely recommend you guys going ahead and trying it out. But also I think what's really cool is this idea of LoRAX. And so what that means is we were able to serve all the production traffic for LoRA land on a single GPU, right? And so all 25 adapters, instead of being served on 25 different GPUs, are actually served on one GPU. And Alex will kind of cover that in more detail later on in the workshop. Cool. And so in this summary slide, I just wanted to show some of the results of our fine-tuned models versus GPT-4. So these are all the models of LoRaland and how they perform to GPT-4. And so I think the main takeaway for me from this slide is, if there was ever a question of does fine-tuning work, I think LoRaland shows the answer is a resounding yes. And so now we'll kind of take some time to talk about the fine-tuning process and the creation of what are called adapters. Sweet. Yeah, so we'll cover adapters and why they're important for you to understand and kind of know about. And then Alex will also cover how you can train your own adapters later on in the workshop. Sweet. So diving right in, I think in the world of fine-tuning, there are broadly two main methods to fine-tune. There's traditional fine-tuning, also known as full fine-tuning, and then there's what we call parameter-efficient fine-tuning. And so in full fine-tuning, you have your data set, and what you're aiming to do is you're aiming to update all of the model parameters during each step of training as you pass over your data set. And so what we find is actually this is very expensive, both from a memory perspective as well as from a runtime perspective, because you have to track the activations and the gradients for all of those parameters in your model when you're updating the weights during training. However, in recent years, there's an alternative that's what I kind of want to talk about today, which has gotten very popular, called parameter-efficient fine-tuning, also shortened as PEFT for short. And so instead of adjusting all the weights of the model as we do in full fine-tuning, in PEFT, what we do is we introduce a small set of weights that are then trained. And then during the training process, we actually only update the smaller set of weights without touching the original base model weights at all. And so the result is that we keep the base model the same, and we have this new set of model weights, what we're going to call an adapter, which is usually on the order of like 1% of the total model parameters, but it tends to match or exceed performance after our full fine-tuning process. And so while it may seem like counterintuitive why modifying just a small set of weights gets you equal or better performance to the full fine-tuning, I think there are a few reasons why this is the case. The first is that most of the knowledge from a base model is actually learned during pre-training. And so since the pre-trained base model already has a lot of the base underlying knowledge, it kind of makes sense that we only need to tweak a few parameters to tailor it to our specific task. And at a more fundamental level, there's also a very common problem with full fine-tuning, which is called catastrophic forgetting. And this is essentially the problem where after you fine-tune, the model actually tends to forget previous information that was learned during pre-training. And so this could be very like fundamental information such as semantic knowledge or how to understand grammar. And this is in the process of learning the new task, right? And so by only training on a very small set of parameters, we're able to make sure that, or at least reduce the probability of catastrophic forgetting through fine-tuning. And so over the last year, one of these adapter-based fine-tuning techniques called LoRA has gotten very, very popular. And so I wanted to kind of cover that and how it works. And so LoRA, again, stands for low rank adaptation. In this technique, at a very high level, the way it works is we introduce two new tensors, A and B, alongside the original pre-trained weights. And so this happens in each transformer layer of the architecture. And during the forward pass, the input from previous layers is then passed through both the pre-trained weights as well as the new LoRA layers, and then summed together before passing it to the next layer in the network. During backpropagation, only the LoRA layers are the ones that are modified, and the pre-trained weights are kept frozen and untouched during the entire training process. And so you can see that the LoRA weights are actually what's learning during your training process. Cool. And so one of the main reasons why LoRA fine-tuning has been so popular is that it's been shown to be just as good as fully fine-tuning for a wide variety of tasks, such as like the glue benchmarks, for example. And so at Predibase, we've actually seen this be true for over the thousands of models that we've trained internally. And so what you see here is this is actually a table of from the original LoRA paper that shows across all these different data sets, what is the difference in performance between the full fine-tuning, FT, and then the LoRA based fine-tuning. And we can see that in the majority of cases, LoRA-based fine-tuning definitely rivals the full fine-tuning model performance, right? And so given this, what's really powerful is the fact that it's also extremely efficient, right? And so as we mentioned before, the number of trainable parameters is less than 1% of the total model size, right? And so there's actually some configurability you have here when you're doing LoRA-based fine-tuning. The number of trainable parameters is actually dependent on this parameter called the rank, which you can increase if you want to increase the number of parameters and teach the model more complex behavior or behavior that may have fallen out of scope of the pre-training. Beyond the lower memory footprint, the jobs are also much faster to train. And so on average, compared to full fine-tuning, it's typically 15 to 25x cheaper to train, as well as 10 times faster to train. And so if you have a fine-tuning method that is not only equivalent in performance to full fine-tuning, but also much, much more efficient, that allows you to just get in more reps and to really build this iterative fine-tuning story where you're able to fine-tune the model again and again until you get the best performance that you're looking for. Cool. And so just to summarize, what is an adapter? It's essentially a small set of trained model weights that are produced during the fine-tuning process that are used to specialize your pre-trained base model to your specific task. Cool. And so with that, I'll hand it off to Alex.
Thank you, Abe. So now we are going to do a deep dive into how fine-tuning of adapters and serving adapters operates. So let's go to the next slide. When we talk about bringing an open source LLM into production, there are two major components involved. One is responsible for fine-tuning the base model on a high-quality domain-specific data set. And the other is responsible for serving the result, the artifact, which is the base model with the fine-tuned adapter. And in fine-tuning, what is fundamentally happening is that we have a mathematical formula. It is a function of billions of parameters, and we're solving an optimization problem. We compute the optimal values of all of these parameters, and optimal means in the sense of giving us the most accurate predictions when we use this model in our application. As part of the implementation, we're faced with a number of engineering challenges. First is finite precision machine representation of floating point numbers, overflows and underflows. If that happens, the result becomes invalid and we have to start again. In addition, because we use accelerators to speed up common mathematical operations, there we're dealing with large multidimensional arrays, tensors of numbers that have to fit into the memory on the accelerator. Graphical processing units, the GPUs, these are now the most commonly used as accelerators for machine learning, and they have finite memory. So if an out-of-memory exception occurs, we have to start all over again. These are the kind of considerations that we have to grapple with when building these systems. And that's just one major part of the system. This is the part, by the way, traditionally, training and fine-tuning, that's the part that's received most of emphasis from the point of view of mathematics, engineering, research, science community. However, the second part, the problem of serving, model serving, is actually even more critical because model serving inference, the inference part, that's what's incorporated in the applications in order to give the power of LLM to our applications, to the systems we build that we serve to users. These LLM capabilities, the serving, is what we integrate in our applications. And so model serving, in fact, is what impacts the operational budget the most. Because while fine-tuning or retraining happens when the new data becomes available and we want to improve our model, inference is happening when the application is used by customers. And that is orders of magnitude more frequent, because this is how we're bringing the power of machine learning into our applications to serve product recommendations, automatically respond to support questions, or generate code. We're building a co-pilot type of tool, and so on. The inference regime is what is powering your application, and that happens a lot more often than training. And naturally, it also uses GPU resources. So these are the two primary system blocks: fine-tuning and serving, plus, of course, having access to high-quality data set for fine-tuning. We at Predibase, the company, maintain two Python open source frameworks. One is for fine-tuning LLMs, that's called Ludwig, and the other for efficiently serving fine-tuned LLMs, that's called LoRAX. Then the next slide, Ludwig, it's a declarative interface library. It has been around for several years. It's a low-code framework. What does it mean? You give it a configuration with the inputs and outputs, the base model, some adapter settings, like Abe mentioned, the rank, and it figures out the hyperparameters by itself. And it does it in a way so as to train your model to fine-tune your adapter in reasonable amount of time using the available GPU resources, and so as to maximize the accuracy of the predictions that you're going to serve when you deploy your model in your application. Ludwig has gotten popular. It makes the life of data scientists and machine learning practitioners a lot easier. Now that we have fine-tuned our model, well, the next thing is to serve it. So let's say that we fine-tuned a base model for a customer support use case. Let's say we want to extract the intent from a call transcript. Why did the customer contact support? So now we approach DevOps and request an EC2 instance, G5 2x large, has a good size GPU on board so that we can host our model. That particular EC2 instance costs about $900 per month. Fine, so we deployed it. Now we decide that we're going to fine-tune the same base model again, but on a different customer support use case, sentiment analysis, for example. We look at caller agent conversations, and we want to extract the sentiment of how the conversation flows. We fine-tuned it where we are pleased with our results. Now what? Another dedicated deployment? That is not cost effective, especially because every GPU in these deployments, in these dedicated deployments, would be extremely underutilized. LoRAX addresses this problem. LoRAX stands for Low Rank Adaptation Exchange. LoRAX packs over 100 fine-tuned adapters for a given base model, all on a single GPU. So as, let's say, request a call for a given fine-tuned adapter comes in, LoRAX routes that request to the appropriate adapter, and it swaps in new adapters as needed based on the use case, while swapping out the adapters that are idle. This is analogous to how virtual memory works in an operating system. With that, the cost savings are over 100-fold compared to dedicated deployments and commercial hosted systems. And fine-tuned adapters often exceed GPT-4 in prediction accuracy. LoRAX has a vibrant open source community of users and contributors, and everybody is welcome to join. So now we're moving on to what our code walkthrough will be about. Let's first describe what we will do. So in our code walkthrough, we will fine-tune 3 adapters for different customer support scenarios and compare their predictions to those of the base model. It is very, very important to treat the base model fairly. We'll talk about this in a moment, but we need to make sure that we are fine-tuning for a reason. So we will choose Mistral 7B, Mistral 7 billion parameters, as our base model because it has exhibited very good performance on multiple benchmarks. And we found through LoRaLand it is easy to fine-tune on a wide variety of domain-specific data sets. So again, it's very important that we make sure that the base model and fine-tuned adapters are compared fairly. So we have to have the same inputs, the same prompts for them. Otherwise, we may not know if fine-tuning is even necessary. But what if the base model is already good enough? So we will do our work in Predibase. Predibase is an LLM fine-tuning and serving platform, which draws from Ludwig and runs on LoRAX. There's LoRAX inside. Predibase, the platform, hides the complexity of provisioning computing resources, including the GPUs, and provides always on, kind of always hot, ready to fine-tune base models and easy SDK for developers, and we will use that SDK. So now, to draw inspiration, we'll build our own miniature LoRaLand for customer support. People may have known the success of Klarna and as being the outsourced customer support auto response provider with high degrees of accuracy. And also Intercom has shown that with the LLMs, they've been able to resolve a lot of support inquiries instantly. And so our use case will also be the kind of a, let's take the inquiry from a customer and process that text and find out what it is, what's the reason why they're contacting support, and try to come up with an auto response that is so accurate that when the user gets it, their problem is resolved. So fine-tuning for us is important. The accuracy is very important because if the results are not so good, then the user will escalate to voice, and that translates into higher costs. So our goal is just get that inquiry, process it, come up with the best fitting auto response that maximizes the user being satisfied that their concern is resolved. And so we'll be the provider, outsourced provider for 3 types of customers. In the customer support domain, there will be payments processor. They take queries about payments. Another one will be about the orders, and the third will be accounts. Even though they're all within the realm of customer support, they're actually different. The focus is different. So these are actually 3 different customers, and we'll see in the way we train and prompt the models for these customers, you'll see there's subtle but very important differences. So now, to frame our problem, we will receive an inquiry, and we will want to do 2 things. We will extract the intent. So what is the reason why? What is the concern of the user? Why are they contacting support? And then we will want to generate a one-shot auto response that maximizes the probability that the user will find it satisfactory. And we will also want to package it in the JSON format. Why? Because as application developers, we will want our code to consume the output and do something else with it. For example, log it to the database, and then that data will be used for generating reports and dashboards so that the quality assurance can examine that and help improve the quality of the customer support department. So we want intent, response, and frame it in JSON. And now, as the last thing before we go into the code, let's talk about the high-level overflow, or high-level overview of the workflow of the code. So the next slide, please. So first, as we said, we will check how good is the base model. How good can it be? Maybe it's so good that we don't need to fine tune, so we can save ourselves operational costs. We will find that that's not the case, but we have to do this step. Then we will prepare the data set for fine tuning. So there will be 3 different data sets, one for each customer, orders, payments, and accounts. I will go quickly through this step. It's just data set preparation, data analysis, data exploration, some data formatting, but you will have the notebooks and you'll be more than welcome to go through it yourself, run it yourself, or reach out to us for any questions or suggestions. So we'll prepare the data sets, and then we will launch fine-tuning in the Predibase platform for each adapter. For each adapter, 3 adapters, 3 fine-tuning tasks. And once the fine-tuning is finished, we will then test how well we have done. We will prompt each of the fine-tuned adapters and look at the output qualitatively to validate that indeed the quality, the accuracy is better than the base model. So with that, may I please share the screen so that we can then go into the notebook.
Hello. It looks like we lost Alex for a minute, so hang tight while we get him back on and we kick off the hands-on workshop. While we're waiting for Alex, now would be a good time, if you haven't, to set up a free trial. You can also open the notebook and start to take a look. So we'll go find him on Slack and bring him back to y'all so we can dive into the cool technology.
Okay, can you hear me?
Yep, we can hear you.
Okay, so let's now continue and go over our notebook. First, we will have to install Predibase and the data sets. So we need the data sets library because we will be sourcing a data set that's hosted on Hugging Face. So we will use the datasets library, and I've done it already. Pip install Predibase and the datasets. Then we do the imports, some typical imports, the dataset types, and pandas, JSON, things like that. And also Google Colab, because we will be loading the dataset from Hugging Face. We will be pre-processing it and then storing it in our Google Drive and then loading it into the Predibase application. So those are the prerequisites. And then we want to sign in to Predibase. When you get a Predibase account, you get a token. So I had my token. And then you just instantiate the Predibase client called Predibase with the API token. And then we also send into Hugging Face. You would need a Hugging Face token to be able to get to some models that are protected by the token. So now that we have done these prerequisites, the next thing in order to prompt the base model is to instantiate the client. Client is the one that has the generate methods to prompt the models. And so from Predibase handle, deployments client, and Mistral 7B is the name of the deployment. It's a serverless deployment, which is always on, available for prompting and fine-tuning. So we get our client, and then we define the options we will use. Max new tokens for generation, which you can adjust based on the data statistics, and the temperature, which controls the randomness variability of the response generation when you prompt the models. So now that we've defined this, let's send a simple question to the base Mistral 7B model. So I can no longer afford the order. Okay, so we send it, we call generate, and we print the text. This is obviously a bit of a messy output, no clarity, repetitive. So we know that it's generating some text, but it's nowhere near where we want to be. We can improve the prompt and give it some more details about the order customer. So we're using the order customer for the example. We can say you're a support agent for a company, receive requests from customers. We can tell it exactly the kind of intents that we expect to exist. It's a finite list. So we help it a little bit, and then we say, well, please reply in the JSON format and do a request. I can no longer afford the order. So we improve the prompt a little bit. Let's generate. It's better, but it's still repetitive. And there's shipping address, some information is shown that's not clearly whether it's needed. But we see there is some motion in the positive direction that is happening here. We can further improve the prompt by doing this, what's called one shot. We're putting one example into the prompt. So for example, here's the example. How do I order a product? And the reply is expected to be this JSON structure: intent, placeholder, one of the intents, and response, an auto response that's deemed to be good quality. So when we prompt our client with that for the base model, we get something that's more JSON-like, but there is still too much information. It's not super accurate. It repeats, and it's also truncated. This is in the right direction, but we can safely conclude that the base model is not of high enough quality to put in a production commercial application. So that means we decide that we're going to fine-tune. So first we'll prepare the data set, we'll upload it to Predibase, we will set up the parameters and launch the fine-tuning task. And so I will go over the data set preparation. We'll load it, and we're using bytext, customer support, LLM, chatbot, training data set. It is an open data set. And what we will do with it through these manipulations is basically look at the category field in this data set. And based on the semantics of the category field, we'll group categories. One group will belong to the orders type application. Another will belong to payments type application, payments semantics. And the third group will belong to the accounts. So this is how we will break down the original data set and create 3 customer-specific, domain-specific data sets. And that's how we get the 3 customers. And each customer will have its own set of intents. That's how these customers are different. So the set of intents for the orders is different than that for the payments, is likewise different than that of the accounts customer. So that is essentially the work of the data set exploration, some statistics, and then grouping as such, so payments, orders, accounts, and then some data cleaning and more exploration. and then creating the completion field. So we have prompt and completion, the completion for training, and then for judging inference completion, we will put together in the JSON format from the intent and the response. And now we will have our data set that all looks like instruction completion. And finally, we have to take the instruction format, the prompt around it for the LLM, and that will be the training data set, and we will hold out some of it for validation and testing. Finally, what's important is to look at the distributions of the token counts in this data set, because that helps you decide what some generation parameters need to be. For example, what is my best maximum token number? And so if you do these quartiles, median, 75th percentile, and so forth, you can actually look at these numbers and decide for each customer what your max output token number should be. So for example, maybe 375 is too big, but if we do ours at 256, we will be better than 75th percentile, and it's okay, it will work well for our demo application. You can change this and decide for yourself what is best for your requirements, but at least we get these numbers so we have a better handle on how we're configuring our prompting. And now that we have done this, so we prepared the data set, we will upload these data sets to Predibase. And we will then kick off the fine-tuning job. We'll kick off the fine-tuning job, and we can monitor from the Predibase UI. And so the prompts, so we have a prompt template, which we've seen before. We asked the support agent to take in the set of intents and come up with an auto response and the intent of a given transcript and put it together in a JSON format. So that's our prompt, and each customer will be different by which intents are pertinent to that particular customer. So we will now have our instruction and the prompt, and we will build that together and create the format that Predibase expects. And now we have full prompt and the completion. Completion is in the JSON, and the prompt has the prompting itself plus the field, the instruction field in it. So now that is complete, we can save it on our Google Drive, and then in the CSV format, and then upload it from file to Predibase. I had already done it, so here I already uploaded, so I'm actually running the get data set. These are RESTful-like APIs, so there's get, create. Now let's go on and do the fine-tuning. We will start with a payments adapter, and then we will also do the orders and the accounts. So that will be the same operation. So we will create a repository, and the repository is important because you can do a number of fine-tuning jobs with different parameters, and you can then choose which of the versions you like the best. You can do these experiments. So we'll create a repository for customer support payments customer and launch the fine-tuning job by having Predibase handle.adapters. This is the fine-tuned adapters, and create. Running create will launch the fine-tuning job. We will give it our base model, Mistral 7B, 3 epochs, generally considered good enough. The rank of 8 is default, and the learning rate, we will give it 2 times 10 to the minus 4. With our data set, our adapter repo, and the description that we're fine-tuning Mistral's 7 billion parameters base model with the customer support dataset for payments. And so this fine-tuning job takes some time, could be between 30 and 90 minutes, depending on the dataset size. And I've already done it. It produced results, and I can get this adapter test to make sure I can obtain the adapter reference. Now we will repeat the same for the orders data set. So it's a very similar operation. There is the prompt construction, creating the data set for Predibase that has specifically the prompt and the completion columns. We look at it to make sure it looks correctly, create the path on our drive for the CSV file, save the CSV file, and then upload it to Predibase. And so since I already done it before, I can get the data set because I will need it for the fine-tuning job. And then the second repository now for the orders adapter, we created a repository where we will have multiple versions of our adaptation processes. We'll see which one we like more. And launch the fine-tuning job now for the orders customers. So this is fine-tuning the base model with a customer support dataset for orders. And again, this runs, looks like here I was running version 2 after the first version. And we can watch the progress in the Predibase UI with learning curves. When it finishes, we make sure we can obtain this adapter. And now we move on to our final customer accounts. So accounts has its own set of intents, and we add them to the prompt. We create the data set for Predibase with the prompt and the completion columns, like for the other two customers. Save the CSV file onto the Google Drive and upload it to Predibase. Create a repository where we can run multiple versions as experiments, and launch the fine-tuning job. Same parameters. Fine-tuning Mistral 7 billion parameters with customer support dataset for accounts, our third customer. And again, once this job completes, we test to make sure everything worked properly. We can get the adapter handle. So we're done with fine-tuning. What remains to do is to see how well has fine-tuning done compared to the base model and in the absolute. So here, because we looked at our statistics, we decided let's make maximum new tokens larger. We'll handle up to 90th, if not more, percentile for all data sets just to simplify it. And we have our adapters now, looks like fourth version in Predibase for the payments, and version 1. We can run any different versions. So these are the ones we have here, orders in Predibase. We can also upload these adapters to Hugging Face if you want to share them with people. And we can prompt either way, from Predibase or from Hugging Face. But here we'll just use Predibase adapters with their versions to check out how well fine-tuning is compared to the base model. So let's start with the payments, then orders, then accounts. Same prompt, always the same prompt. Here is the intents for the payments, so invoices, refunds, payment issues. And the same request, please give us the intent of the call, auto response, and package it as JSON. When we look at the result, it's a significant improvement. The intent is crisp and clear. Check refund policy. Respond. I'll take care of it. I understand you need to have a clear understanding of the situation in which you can request a refund. Here are some common scenarios. So now it goes to provide a very good answer. The user will likely be satisfied, mark the ticket as resolved, and not escalate to voice, not ask for the supervisor. And then we do that the same check for the orders. And so we have it's a different customer, different intents, tracking order, change order, cancel order, things related to orders. We prompt it, and we get we get for orders here is the answer. So the orders, we get cancellation order intent, and the response, I've understood you're facing financial difficulties and the need to cancel your order. So that, again, looks like a significant improvement over the base model prompting. And so the user is likely to find this satisfactory. So here we prompted our fine-tuned adapter. The difference between prompting the base model is we provide the adapter ID and its version. Finally, let's do the same for accounts, the accounts customer, and that has to do with recovering passwords, registration problems, things of that nature. And we give it accounts adapter name, version 1, and look at the response. Crisp intent, one of the available intents, and the response, I'm on it. That already should give the end user confidence that this will be high quality response. So we have much easier feel about putting fine-tuned adapters based LLM systems into our applications for production, because we believe that our business will generate high quality responses, give us good information about intents of the call, produce JSON so that it can be used, put in a Postgres database and do queries, reporting, dashboarding from then on. So that's a clear win for the fine-tuning process. So that kind of concludes the code walkthrough. You have these notebooks and other resources. Thank you for following along. Hope it's been helpful. And I would like to pass it back to Abhay.
Awesome. Thanks, Alex. Let me go ahead and share my screen. Sweet. Yeah, so we just have to recap what we learned, kind of building our own LoRa land. Hopefully you're able to kind of follow along with both the fine tuning and inference part. If you didn't, we will be sharing the notebooks afterwards. But just as a quick kind of recap, the trained adapters that we trained today actually are on Hugging Face right now. So if you go to huggingface.co/Predibase, you'll see our company page where you'll see access to both the adapters that we just trained today, both the accounts, payments, and orders models, as well as actually all of our LoRa land adapters are there as well for your reference. Cool. I'll pause here for a little bit, but yeah, there are a few notebooks that we wanted to kind of leave you guys with today. The first is what we covered today, which is our deep dive fine-tuning and serving. Here's the URL. We also shared this kind of earlier in the presentation, but there are two other ones we wanted to kind of point you towards as well, if you're curious. If you do have like an example and you just want to get started with a bare bones example, we do have an end-to-end example in our docs, which is very, very short, easy to get started. It's at pbase.ai/end-to-end fine-tuning example. And then let's say you actually already have your own adapter, maybe you trained it somewhere else, and you want to use Predibase for serving. We also have an example where you can bring your own adapter from Hugging Face and serve it on Predibase for production grade inference. So I'll leave these here. We'll also kind of share these in the chat as well. But yeah, a bunch of notebooks that can be helpful depending on where you are in your LLM journey. Cool. And then before we wrap up, just want to say that we are kind of reachable. We're happy that you joined us today, but you can also find us, actually the whole team on Discord. So we have a joint Discord for both Predibase, which is the managed offering, as well as our Ludwig and LoRAX open source communities. It's at pbase.ai/Discord. Would definitely recommend joining if you're interested in Predibase, but also if you're just interested in the open source or just kind of want to learn more. Very, very vibrant community. And then also if you do have kind of questions or comments as you're using Predibase in the free trial, where we can also be reached at support@predibase.com. Cool. So with that, I think we'll open it up to Q&A.
Yeah, great. So a lot of questions, a lot of interaction, and our team has been answering many of them. But I'll ask you guys some of them live. And so some of the questions, one was early on about sample data set size. Any recommendations around that?
Yeah, I'm happy to take that. And one thing, and it's been described in a number of scientific papers, is that for fine tuning, the key thing is for your data set to be very high quality. And we have seen excellent results with data sets, depending on the domain, depending on the application, depending on the base model. But we've seen excellent results with data sets with as low as few as 3,000 high quality samples. But typically we train on 10,000 to 15,000, sometimes 20,000. The quality, proper distribution, proper sampling, unbiasing, making sure there's very balanced data set is a lot more important than the numbers, as long as you're above certain nominal range. So for us, from 3,000 on to 15,000 has shown good results.
Great. And maybe real quick, some questions around, do we deploy on premise or different deployment options for Predibase? Maybe you can just briefly talk about options people have if they wanted to use the platform.
Sure, I can cover that. So I think there's two main ways to deploy that we offer. One is our SaaS offering. So this is where we kind of manage all the compute behind the scenes for you. So if you want to just get started very easily, that's where you can go ahead, run free trial, sign up, add a credit card, and you'll be on our developer tier. If you are interested in deploying in your VPC, we can deploy into any of the three major cloud providers. So that's AWS, GCP, or Azure. And the way that works is we have a hybrid control plane and data plane, and we deploy the data plane directly into your environment. So the data and computer are co-located, and the data never has to leave your environment.
Nice. Another question. So there's a couple of questions discussed around how do you evaluate the performance of the models, different evaluation techniques. Maybe you speak briefly about how we do that perhaps for LoRaland and maybe some just general best practices.
So you can evaluate on general benchmarks, the blue, the rouge, but you'll find that for a lot of domain applications, they're not so good. They're not reflecting of your business use case. One can often, after doing these standard benchmarks, we can also do a small sample for human experts. And just in general, domain experts coupled with standard metrics and more of equivalent analog samples based on similarity, based on quality, usually it works well. One has to adapt to their domain of interest and find the right metrics for that.
Got it. And then sort of on that, talking about data sets and evaluations and all that. So I want to ask any just general tips for data set prep when fine tuning?
I would say that data set exploration, like going slowly and meticulously, cannot be underestimated. And cleaning is towards the application you have in mind. Like, are numbers important for your applications? What kind of words are not necessary? It may be playing a less role in a general LLM, but when you're fine-tuning for your specific customer case, if you're helping a retailer who sells music versus a financial application, the needs are different. So one has to have their application, the end use case in mind when they look at the data set. Is it anomaly detection? It's harder. Is it code generation? That's different too. So going through finding very, very high quality samples, getting rid of some examples that will only pollute the data set and confuse the model. For example, you can clean entries that have fewer than 10 tokens. They're not going to be useful unless that's an intent. So one really has to spend time and assess quality of the data set, the numbers, make sure there's no leakage from the training set, from the test set to the training set, so the model doesn't suddenly become excellent for not very good reason. So those are extremely important steps before that data set is submitted to the fine-tuning job.
And one thing I'll mention too, and there's a question about size of data sets, and I think you had a pretty thorough answer, Alex. When we looked at LoRA land, I think it was about 17 of the, so almost 80% of the models had data sets that were smaller than 20,000 samples that we trained on. And so we're getting performance right that was outperforming GPT-4 on almost all the tasks with relatively small data sets. So, if you have a good, clean data set, as Alex mentioned, you can get really good performance without needing hundreds of thousands of rows.
If you would like, if you're interested in further scientific studies done in this, for this particular question, please come to our Discord, and I'll share a paper from earlier, I think from mid 2023, that actually has extensive experiments on the data quality and data sizes for fine tuning.
So I wanted to ask, how many adapters can you load in parallel using LoRAX and Predibase?
That's a great question. At least 100, and you get proportionally cost savings compared to OpenAI. And it also is limited by the actual GPU that you have. So obviously, if you have a very large GPU, and by the way, Predibase, of course, aggregates large GPUs, more memories, you can fit more. They're all stay resident in memory. But at some point, even the largest device runs out of resources, and then there's a process for yanking out the ones that are not used, so that the one that needs to be has the resources to operate.
And so I wanted to ask, what GPUs are we using behind the scenes for this specific set of experiments we ran?
So we run on A100s. We have in Predibase H100s. You could fine tune on smaller ones as well. Really depends on the base model size and the data set size as well.
Just a general question, maybe when you're thinking about base models, do you have a checklist you go through before deciding which one, or how do you think about which base model to select for fine tuning? Maybe run multiple experiments, kind of see which one tends to perform best. What's your best practice there?
So when base models come announced, especially if they're open source and available for commercial use, which is of great interest to us, we jump onto to categorize it, evaluate, and see. We read literature. We also look at the benchmarks, human evals, and if there's a good sign, right away we'll try our experiments. You can read all sorts of theory and descriptions and testimonials, but code doesn't lie. So we actually have the data sets, including the ones that you have seen in today's notebook, and we start running various experiments, experimental parameters, measuring and seeing. One of the aspects is the base model going to be amenable to fine-tuning, not just, let's say, on customer support, but maybe on code generation, maybe on math and other things you could see in LoRA land. How widely applicable is it? And then we share our findings with the community.
And we actually are publishing a paper, an archive paper, very shortly here that summarizes the findings of the LoRA land models across those 25 different tasks, so you can see at a task and model level how they performed. Sorry, Abe, were you adding something?
Yeah, I was just going to say, we have that paper coming out. I just put a link in chat. We also ran a previous webinar where we did compare different base models. So if you are curious about where to get started, I would definitely recommend giving that a watch.
And you can find that on our YouTube channel as well. So when I'd asked earlier on, what models does Predibase support? Abe, I know you spent a lot of time on this.
Yeah, we actually have this available in our docs. So I would, if you go over to docs.predibase.com, we have a section for both our inference and fine-tuning models. We are planning to kind of consolidate this in the near future, but as of now, you can kind of see what we support as both serverless endpoints, what we support for dedicated, and what we support for fine-tuning. If there's a specific model you're interested in, definitely let us know, and we can look into adding it if it's not already there.
The link is docs.predibase.com/user-guide/inference/models. It's all there.
So go ahead.
Yeah, go ahead.
I just want to also ask if there's a data set that's not from Hugging Face that they want to use, does that get stored in the Predibase cloud? How does that work?
What is the question?
Oh, so if someone has a data set that's not from Hugging Face, they want to bring into the platform to fine tune on, does that get stored on the Predibase cloud?
Oh, I see. Yeah, if you're using our SaaS offering, then yes, we will use it for like when we run the training job. Let's say you have like an S3 connection, we'll pull in that data set at runtime, use it for training. And actually what we store is actually just the connection, not the data set on our side, right? And so we're very conscious about data privacy. And so if we don't need to store the data set on our side, we won't. And then for VPC, obviously the data lives in your environment.
Sort of building on your question, Ave, I know we have a pretty broad-ranging list of support for models. Someone asked, do we plan to support Mistral 8x22b? And if we don't, like, can someone use that model specifically in the platform?
Yeah, for sure. I think they're probably talking about Mixtral 8x22b, like the Mixtral experts model. Yeah, I don't think we have support for it at the moment, but it's definitely something our team has been aware of, and we're looking to add support for it in the near future. We don't have a timeline for that yet.
Someone asked, can we fine-tune Llama 3? I know the answer, I'll let you answer it.
Yes, definitely. Try it out. It's in the free trial.
You can start prompting it, fine-tuning it, and we will be, if you come to our blog site in probably a couple hours from now, we have a fine-tuning blog that we're about to publish for Llama 3 specifically, so you can follow along with that do-it-yourself tutorial as well. Just going through to see if we missed any other questions.
I just wanted to also mention that when somebody asks us, can you fine-tune and gives a new model that, or some models that are not even fully integrated in public repositories, the answer has to be conscious of those two parts we talked about, fine-tuning, but also serving efficiently. So we have to make sure it works. Fine-tuning and LoRAX works as well. Then we can say resounding yes, and provide examples so that people can just copy paste code and do it like what we've done in Notebook today and run it for themselves.
And someone was asking, if we're fine-tuning on Predibase, if we want to download that model, run it in an offline environment, can we export models? A couple questions around that. Is that possible?
Yeah, totally. We're very big on like owning your models, and so any models trained on Predibase are yours. You can choose to use them for inference in the platform, and you can also choose to download them and serve it externally as well.
Someone had asked, do we today support external vector databases for RAG? Is that something we support or plan to support, Abe?
Yeah, good question. So Predibase is primarily a platform for LLM fine-tuning and serving. We don't really offer a vector database as such. We do integrate with some RAG frameworks, so things like Llama Index and LangChain. But in that case, we're mostly used as a model provider. And so if you would need to use any open source model like a Mixtral as part of your RAG pipeline, that's where you can kind of serve that model using Predibase. And we're also planning support for embedding models in the next few months as well. So something to look forward to.
Got it. So I wanted to ask quite a bit earlier, like how do you compare sort of like Predibase to some of the other platforms, commercial sort of LLM serving platforms and the platforms that might be out there? Abe, what do you see as sort of the differentiators?
Yeah, I think there's a few. I think in terms of commercial LLMs, we talked about some of the pain points that people kind of face in terms of cost and latency. So specifically, if you're looking for open source models, I think Predibase is the place to go ahead and fine tune and serve that. We do see some users that actually don't want to fine tune; they just want to serve kind of large models for inference. You can kind of use Predibase just as a serving platform or as a both fine tuning and serving. In terms of differentiators, I think one that we obviously covered today was LoRAX. So if you do have multiple adapters that you want to serve on a single GPU and get huge cost savings, I actually don't know of any other providers out there that do that. And so that's definitely a huge cost savings for one.
Got it. And I would say that Predibase has like probably best-in-class fine-tuning experience, so, robust set of features that are both very easy to use and go pretty deep that are not always available on other platforms. So it's been asked a couple times. How do you guys think about fine-tuning vis-a-vis like RAG?
Yeah, I see that Oliver just said fine-tune for capability, RAG for knowledge. I think that's like generally right. Yeah, maybe just like a little bit more context there. I'd say like RAG is very useful for when you have data that's like frequently changing, especially when you're doing like a Q&A type use case over a set of documents. Fine-tuning is very versatile. Conceptually, what's happening is RAG is you're kind of fetching relevant snippets and doing in-context learning, whereas fine-tuning is more about changing the underlying model weights, right? And so if you have a very specific task where you want the model to respond in a certain way, or produce structured output, or produce a sort of set of classification, that's sort of the use cases where we see fine-tuning to be much more useful.
Got it. I think I've gotten to most of the questions here. Sorry if I've missed them. There's a lot, kind of already answered and embedded. Just going through one more time. So, and I don't know if we have a perspective on this. We'll ask it. How to prepare data sets for dialogue outputs, especially in learning and development. I don't know if we have specific experience with those data sets yet, but maybe Alex, you have a thought on that.
Yeah, so I think I understand the question, the problem, and we would have to think about it. Cal, who asked the question, I would encourage to get in touch with us in Discord so we better understand the use case and see what the gaps are and how can it be, how to frame the problem. So clearly, dialoguing is a big part of interactive systems, including customer support. We just need to learn more and see what we can do and when. Abe see on the roadmap, but it's very interesting to even better understand the problems. So yeah.
Okay. Oh, yeah. Here's one we missed earlier that Tom had mentioned. So apologies for that. Have we done any experiments with prompt tuning and/or prefix tuning to compare them to fine tuning, or combine them with fine tuning to further improve the results?
Well, we have actually an upcoming YouTube video by a user who did a study, like small scale but very telling study, where they increase the complexity, sophistication of their prompt, and then take that, the best prompt they could have come up with, and go to fine-tuning and publish the results. That's a small-scale study, but in general, these kind of efforts, as long as you do them incrementally, know which one variable you're changing, so that you know what's improving, what's hampering progress, is definitely a good way to go. Obviously, when you increase your prompt with more than one example or other enhancements, token count could increase, so the speed might decrease, cost can increase, but these are the kind of experiments one can do.
Got it. And Oliver, love the feedback. More sessions on data prep to improve your fine-tuning jobs. Yes, we'll add that to the repertoire. So I had a question about fine-tuning our online models or ones that are rather in production. Where would you update an adapter with new examples every day? Like as an example, you have new examples coming to fine-tune it. Do you need to retrain it from scratch? Any thoughts about how to approach that within Predibase or in general?
Yeah, I can speak like what we have with ongoing, continuing tuning, but in terms of frequency depends on the application and use case. Nobody says you have to be retraining every week or every day or every month. It really depends on what your customers expect. But in terms of the technological capability, Abe, say about our continuing.
Yeah, I think what we see probably most users do is this idea of like iterative fine tuning. So with this, even if you have new data coming in, just setting up a pipeline so that you're able to kind of rapidly run fine tuning experiments. And actually to this end, we actually just had a release last week where we launched up to like 10 times faster fine tuning. And so especially if you try like a lot of other platforms out there, it might take you a day or two, even with OpenAI, to get your fine tuning job complete. Now we're seeing jobs that are completing in the middle of in the range of like an hour or two on Predibase, right? And so given that you're able to kind of fine tune much faster, this definitely opens up the possibility for you to iteratively fine tune much more rapidly.
Cool. A couple more interesting questions that came in. Let's say you've been doing some prompt refining, prompt tuning, and you're not seeing good results. You've tried a few examples, you've hit the token limit. Is that when you would say go to fine tuning, or when do you think, like, is there a good rule of thumb on when to fine tune versus just keep engineering your prompt? How do you think about that workflow or best practice?
Yeah, that's definitely one use case we've seen for fine tuning is people that are trying to shove their context window with a lot of tokens, and for whatever reason, if they're using GPT-4, for example, those costs tend to add up. And so with fine tuning, what you can do is you can actually encode a lot of that base like prompt template type information directly in the model during training time, so that at inference, you don't have to feed in those same tokens for the model, right? And so I don't think that's the only use case for fine tuning, but it definitely is one that we see is reducing costs associated with token usage.
Got it. It's an interesting one. I don't know if we had a strong perspective on this, but maybe Alex, is there a reason why we chose to fine tune like the base Mistral versus fine tuning Mistral instruct?
We've done both. Instruct is good. So no particular reason. Sometimes try different models, see how they do, but ton of experiments with instruct. All go ahead. No issues.
And I don't know if we've done this before. Any insights on fine tuning time series data? Have we done that before?
So we have it out in the past, but the time series things are tricky and each use case is different. I requested the user, Rowan, to reach out to us in Discord so we could better understand it and bring back to the team for discussion. We've done that with Ludwig in the past. We've seen in our context some time series results, but time series is tricky and I'd like to learn more about the needs.
Got it. And then I don't know if we've spent a lot. I mean, you talked a bit about kind of continuous training, Abe, but in our experience, we have some with it. Do we ever see a breakdown or get some sort of negative regression on the model? Have we seen that happen over time? Any way to assess that? Again, not sure we've gone deep onto that topic, but I thought I would just ask.
No, not really.
Got it. So I don't know if there's an answer to this either, but we'll probably wrap it up after this. Is there a general template that can be used to fine tune all models?
Is there a general template that can be used to fine tune all models? I mean, I think with Predibase, all you really need is your data set, right? So as long as you have your data set, we make it very easy to fine tune pretty much any model you'd want out there. So maybe you're looking for Predibase. I don't know if there's something else to that question, but the main ingredient you'd need is just your data set.
Yeah, the nice thing about Predibase, right? We've built in a lot of the best practice techniques under the hood and into the prompting, so or into the fine tuning rather. So it takes some of the best of research, and so it gives you a really strong starting point without having to really customize a lot of those parameters. Maybe one more, because I know something we've talked about internally. Any tips on fine tuning to get structured outputs consistently, like JSON or YAML?
Yeah, that's a good question. We actually, I think last month, built an integration with an open source project called Outlines. I can kind of find that blog for you, but basically what we found is that doing structure, using a project like Outlines gets you really good accuracy in terms of enforcing the schema. But when you go ahead and combine that with fine tuning, you can get very, very high performance numbers in terms of generating structured output. And so that's sort of our recommendation is to use in our integration with Outlines in terms of enforcing the schema as well as fine tuning. And I can go ahead and find that.
I posted it while you were talking.
Awesome.
I want one more question because this was asked for. I think we had missed it. Do we support VLM models at the moment?
Yeah, I think VLM is a pretty popular open source project. I think what we typically recommend people to use is LoRAX, just given that we are kind of using LoRAX under the hood and it is an open source project that we maintain. There's obviously some overlap there, but we'd probably suggest starting with LoRAX. All
right. I think with that, we're going to call it. We want to thank everybody for joining today. If we didn't get to every question, apologies. We tried to do that as much as possible, but you can join our Discord. I'll paste the link one more time for folks. Join our community. We will be in there talking, sharing. The community, obviously, you can tell, loves to share. So if you join the conversation, and we're happy to answer your questions and even, explore experiments with you. And as a reminder, for those who didn't today, we're offering $25 in free credits. The button should still be there, but you can go to Predibase free trial, try the platform for free, including Llama 3, prompt it, serve it, fine tune it, all of it, and have fun with it. But big thank you to our speakers for spending almost an hour and a half with us here. Great job today, folks. And thank you everyone who joined and participated. Love the dialogue, love the interaction. And we love learning from you too and all the good ideas that you shared for future content. So thank you very much. And we'll see you in a couple weeks for our next webinar where we'll talk about how we accelerated, improved fine-tuning on our platform by about 15x in just about 15 days. We'll share some of those deep dive techniques that we implemented so you can kind of get under the hood with fine-tuning and learn more. So stay tuned for that invite. It'll be coming out shortly. And yeah, we'll see you soon. Thanks, everybody.